lesson 6-7 is inverse relations and functions. And I will tell you, I'm not going to say you remember it, but there's definitely some review in what we're doing today. Okay, definitely some review in what we're doing today. We've talked about functions. I think that was first semester. And if you remember more, you can let me know. But we talked about functions and how to know if something's a function first semester. We're going to now talk more about inverses. We're still going to talk about functions, but inverses. So, starting off here, inverse relation. An inverse is a relation that pairs an element of its domain to element B of its range, has an inverse relation that pairs B with A. In other words, in a typical function, you have domain, range, yes? The inverse flip-flops the numbers. That's all it does. It flip-flops your x values with your y values. That's what we're talking about with inverse. So, for instance, here's an example of a relation. You have the ordered pairs 1.2, 1, 2, 4, 0, -8. What do you notice in the inverse set of ordered pairs? They are just backwards, right? Opposite. So 1.2, 1 becomes 1, 1.2. 2, 4 becomes 4, 2. 0, -8 becomes -8, 0. So when I ask you to find inverses, you're just flipping, switching x's and y's. Now, do notice you will usually see for inverse notation, it's f, and it looks like it's to a power of -1 is what it looks like. Okay? But that is your inverse relation. We are just flip-flopping our domains and ranges. So let's try example A. They give us a function, set of ordered pairs. Actually, hold on, it doesn't say it's a function. They give us a relation. What's the inverse? What's the inverse? If one of my ordered pairs is 0, -1, what's the inverse of 0, -1? -1, 0. What's the inverse of 2, 0? 0, 2. What's the inverse of 3, 2? 2, 3. And what's the inverse of 4, 3? 3, 4. Okay, that's the inverse. Easy peasy when they give you a set of ordered pairs. If only it was always that easy, right? But they give you a set of ordered pairs. They want the inverse. Just flip your x's and y's. Now, I'm going to jump down a little bit and talk about C. C asks us to state whether the inverse of the above tables are functions. And how do we know? You guys remember about how to tell whether something is a function? I don't know. What do you remember, Lorna?
I think it's x. It can't have, like, if there's like a 2 and it has a 3 as its y, there can't be another 2 with a different number.
Okay. Yep, I agree. The short of it is your domain values, which my domain are my x values, right? My domain values cannot repeat. Okay, so Lorna's example was if we have the ordered pair 2, 3, I can't have 2 then paired with 5, because then my 2 would be repeat. Okay, so with that in mind, is this inverse a function? Yeah. Do any of my x's even repeat? No, so I don't even have to consider anything there. So is this a function? And then explain. So I'm going to say function as in, yes, it is a function. And the idea, part of it is, yes, you can say that the x values don't repeat. But more official, each x value pairs with each y value, one y value. So each x value pairs with, I'm going to say exactly one y value. Okay, so the inverse, we took our x's and y's and we flipped them, flip-flopped them. Yes, this inverse is a function because each x is unique, and each x pairs with its own y then. Okay, ready for B? We have the ordered pairs 0, -5, 1, -4, 2, -3, 2, -3. You got an inverse written down? What's that first ordered pair in my inverse? -5, 0. Good. Flip-flopping. What's the next pair?
-4, 1.
Okay. -4, 1. Next pair?
-3, 2.
-3, 2 and -3, 2. Inverse? Love these inverses. So easy, right? So easy, it's boring. Is this inverse a function?
No.
Yes.
Yes.
We have disagreement.
Functions can't.
If it's the same number, they can't
Numbers.
repeat. It just has to be the same y value.
Okay.
Look at you guys being logical.
Okay, so the issue that is causing the disagreement.
Because the up one is a function, and because of the way teaching works, the bottom one has to not be a function.
If only that was true this time.
So it's a function.
Okay, and I agree. I do often teach that way. However,
You forgot about the trick question.
this is our trick question of the day. Okay, and the idea, each x value pairs with exactly one value, y value, correct? So here, the x value of -3 pairs with the y value of -2. This x value, the repeated x value of -3 pairs with the y value of,
It still does that, so.
it still pairs with that same 2, doesn't it? Okay, so it is the trick question when it comes to functions. And so this one, even though you don't, Noah's convinced that it needs to not be a function because that's how I usually teach. He didn't account for the trick question. Okay. It is a function because each x value pairs with exactly one y value. I'm going to write the same description I wrote earlier. I might put a little extra on it, but each x value pairs with exactly one y value. Now, the trick on this one was the repeat pair. Repeat pairs the same x value with the same y value with the same x value, right? And that's why it worked. So, if I put a little asterisk note here, the repeat pairs the same x value with the same y value. Okay, so if you want a side note to yourself of, wait a minute, why did it end up being a function even though that x repeats? Don't just solely go on, I know you're taught, oh, x repeats. Check those y's out before you decide for sure. Now, do you have what you need from that page? I am going to put something in C there. because we're going to play the what if game. I'm going to throw another example at you. Because C says state whether the inverse of the above tables are functions. How do you know? We already did that, yes? Okay. I like my what if games, so what if these were the pairs? What if it was -5, 0, -4, 1, -3, 2, and -3, +3?
Do we do the inverse? Or just
No, we're not doing the inverse. I just want to talk about function.
Not a function.
Why?
Because you have the negative 3 there.
For times the charm.
it's because they don't have the same range value.
Okay. This time, that x value does pair with two different y values, doesn't it? The first time -3 pairs with 2, the next time -3 pairs with 3. And so this one is not a function because that x value of -3 is paired with two different y values. Is that better now that you have an example showing not a function?
Why wouldn't they just make this like a vanilla function? That's making sense.
I had to show the trick. I had to show the trick option too.
People that
No, I don't agree. I just think
No, he said
you did just agree. No, what? I just
He
think
said the
it's
second one should have been
not a function.
not a function. Yeah.
I agree that it is a function.
Are you guys a teacher?
Shut up.
When you get your master's degree,
Respect.
then you can argue with me.
Once you get a master's degree, then I can listen.
I don't think anybody's arguing with Mrs. Sargent. I don't know where you can argue with Mrs. Sargent from.
Oh God, no! I don't have death. She probably has my mom's phone.
Yeah, same.
I'm sorry.
Well, your brother is my son's age, so
Exactly.
I think she
it
has
probably
mine.
is in my phone.
I think she has mine too.
Okay, guys. You get what you need from there. If you've peeked at the backside, you see the backside we get to find inverses, but they don't give us a nice, neat list of numbers, do they? They give us an equation on the backside. So I'll talk about the directions here, but it's how we find an inverse based on an equation. And so we've got some basic steps here that I want to talk about of how we find the inverse. First of all, the graph of f of x and the inverse of f of x will always be reflections of each other over the line y equals x. Are you guys familiar with what the line y equals x looks like? And notice it's the perfect diagonal line is what it says. But the perfect diagonal line is that line that goes through 0, 0 and has a slope of 1. So that's the idea, and maybe I should have, I don't know if I dare try and draw a set of xy axes on there, but that's the idea of the perfect diagonal line. So if a function and its inverse are truly a function and its inverse, they do reflect over there. Okay, so that's good to know. Now, when we actually go to find an inverse, we are going to switch the variables x and y with one another. So we're going to take x, we're going to replace it with y. We're going to take y, we're going to replace it with x. And then we will, like any typical equation, we're going to solve for y. So our goal is going to be to get it in that y equals form. For an inverse to be a function, it must pass the function test. Either we talked up above about the x's can't repeat, right? Or, you guys remember the vertical line test? Vertical line is up and down, yes. You draw a vertical line, and if it is a function, it can only cross that vertical line one time. Okay? So those are a couple of ways to know if it's a function. And then when we get done, instead of saying y or f of x for the inverse, I say it as f inverse of x. So again, it looks like that f to the -1 power. And so I will always encourage you to write that for your final answers. Okay. Ready to try it? And we'll see how timing goes. I don't know if we'll do all of these. I don't have them all done in my notes right here, so. Example A. What is the inverse of the relation? So y equals x squared minus 1. What do we have to do to find our inverse? Take x, take y, switch them. Just like earlier we were switching x and y numbers, now I'm going to switch x and y variables. So step 1 is going to be switch x and y. So instead of y equals, what's y become? X. Instead of y equals, I'm going to say x equals. Instead of x squared, I'm going to say y squared. So instead of x squared minus 1, it is,
So the y squared just stays with it.
right. You don't move, you just switch the x and the y. The squared stays where it is. Everything else stays where it is. You just take just that variable. Okay? Now, after I switch x and y, my job is to solve for y. So, typical equation solving you've been learning since middle school. How do I get y by itself? So if it's y squared minus 1, the first thing I need to move is the minus 1. How do I move a minus 1? We add 1. If we add 1 on one side, you add 1 on the other side. What is x plus 1? X plus 1, right? Still a question you need to know. And then on the other side, you have y squared, and the minus 1 plus 1 will cancel. Now, how do you guys feel if I go ahead and flip-flop my equation? Are you okay with that? Okay, either here or later. I mean, if you'd rather say, okay, x plus 1 equals y squared, at some point I would encourage you to flip-flop the sides. Am I done? Do I have y equals? No, I have y squared equals. How do I get a y squared to become a y? Square root, right? Isn't that what we were doing in the first half of the chapter? Okay. So we're going to take the square root. If I take the square root of y to the second, you're going to take the square root of the right side. What is the square root of y to the second? Y. Remember, a square root and a square cancel each other out because this square root is a 2 right there, isn't it? So the square root of y squared is y. What is the square root of x plus 1? Square root of x plus 1? Okay. Now, let me ask a question. What are we supposed to be doing when we take the square root in an equation format? When you take the square root in an equation format, what am I trying to always get you guys to put on that right side? Plus or minus. Okay. So do remember, when you take the square root in an equation format, you have to tag on that plus or minus, unless you know for a reason you don't need it, which here we need it. Okay, so we switched x and y, and then we started solving for y. Now we have y equals, yes? And then on the front page, we mentioned something about don't leave it as y equals. What do we write it so we know it's the inverse?
That's the minus 1 and
Yeah. I read it as f inverse of x. So basically just take your y and replace it with f inverse of x. So f inverse of x equals plus or minus the square root of x plus 1. Now, that's all the directions say to do there, aren't they? However, I think there's something about knowing if these are functions in the homework. I don't remember how it's formed, but is this a function? And this is a tough one because do you know what this graph looks like? And you guys don't, do you? Which is fine. I don't expect you to, but a couple of different ways we can tell if this is a function. First of all, let's pick a number. I'm going to pick 3. If I put in 3 for x, what do we get out? 3 plus 1 is 4, and the square root of 4 is 2, except what's it say? Plus or minus 2? So what's that look like if you think about ordered pairs? That is 3 comma 2 and 3 comma negative 2. Is that a function? It's not, is it? So that's one way, is if you take a number and try plugging it in, see what happens. That's probably the easiest way for me to tell you on that one, that this is not a function. But I have one other way. I am really running into B. Go back up to this original equation. What does the graph, I know you don't know what this final graph looks like. I'm not expecting you to remember that or to know that. But I am expecting you to be able to tell me what y equals x squared minus 1 looks like. What does y equals x squared look like? Parabola? Have we done parabolas this year? Remember our u's? That's y equals x squared. What's y equals x squared minus 1? The graph goes down 1. So right here, that's y equals x squared minus 1. What happens when I reflect that across a diagonal line? And I know that's hard for you to visualize, but if we reflect this across the diagonal line like that, so if I could take my bin Q and fold it at that line, what's my parabola going to look like? It's going to be a sideways parabola. Does a sideways parabola pass a vertical line test? No. Remember a vertical line test? If I draw a vertical line, that vertical line just touched that sideways parabola twice. And so that is not a function.
Wait, why wouldn't it go like this? Like it's here and it flips over.
Like upside down?
Yeah. Wouldn't it be like
It would flip upside down if you had a horizontal line to reflect it across. So like if you were reflecting across the x-axis, then it would just be perfectly upside down. I know, it's hard. It's kind of hard to visualize. It's one of those I probably need to like put on a piece of paper and try and have you guys do that way. But okay, so I'm just trying to mention this whole is it a function or not, because that is something you're going to see pop up in homework. So I don't want you to be totally caught off guard there. Okay, we're supposed to be doing B next. I promise. I kind of ran out of room, but okay. Try this again now. Got the basic steps? If it's y equals 2x plus 8, what's the first step in trying to find the inverse? Switch, right? So we're going to switch x and y. So instead of writing y equals, I'm going to write x equals. Instead of writing 2x plus 8, I'm going to write 2y plus 8. After I switch, what do? Get y by itself. So this goes back to equation solving. If it's 2y plus 8, how do I get y by itself? It's plus 8, we're going to subtract 8. What is x minus 8? X minus 8 equals 2y, because my 8 minus 8 will cancel. And then I heard if it's 2 times y, I'm going to divide by 2. Now, there's a couple of different ways we can think about this. And honestly, I'd be fine with a couple of different options here. Math Excel, I don't know what to tell you. One option okay, obviously 2y divided by 2, the 2's are going to cancel. Right here, if you're doing this for me, I am fine with leaving it as x minus 8 over 2. Math Excel might be fine with that as well. I can't guarantee anything. Okay? However, if we're going to talk about what this looks like in order to know if it's a function, I'm going to have you think a little differently in that, how do we divide this 2? This 2 divides into x and 8. So if I think about this as x divided by 2 minus, what's 8 divided by 2? 4. Now, I know some of you may be thinking, I still don't know what that looks like. What's the invisible number in front of x?
1.
There's a 1 there, right? Okay, it came out weird. So this x over 2 is also the same as thinking 1x over 2, which means you could think of it as 1/2 x. Can you visualize the equation 1/2 x minus 4? What is that an example of? That is a line, right? There's a slope and a y-intercept. Is a line going to be a function?
Yes.
Yeah. A line's going to be a function, and that's what I was trying to get you guys to think of there. So that's why I kind of liked going better there. As I write this in final form, a couple of comments to make here. F inverse of x, you could write equals x minus 8 over 2. You could write x over 2 minus 4. You could also write 1/2 x minus 4. But as we think about whether or not that's a function, it's a line. And if it's a line, does that pass the vertical line test? Yeah, I can draw a line there, and it only touches once. If we pick a random number to put in here, 10. 10 divided by 2 minus 5. Excuse me, minus 4, whatever. Okay, but if I put that number in there, can I get 2 answers out or only 1? I can only get 1 answer out. So all of that to say, the point I'm trying to make, is this a function? Yes, this one is a function. So there I'm going with Noah's line of thinking that a not function example, a function example.
Yeah.
The predictable. Okay. Where am I at?
But how would you
So
draw
therefore,
like
if this one's not a function.
Well, I went off, this is kind of like the form of y equals mx plus b.
Mhm.
And so I'm just looking at the fact, I was just trying to get the shape of the graph. But like this would be a y-intercept of -4, and this would be a slope of 1/2. So if you go up 1 over 2, like if I have a point and then I go up 1 over 2, that's kind of what my,
Oh, yeah.
okay. So I was just trying to show, I didn't draw this specifically. I'm trying to just show it's a line. And the difference is up here, this line would have had the original would have had a steeper slope, is what would have happened there. This one is less steep. Does that help a little bit?
Yeah.
Okay. Okay, let's try C. Y equals square root of x minus 2. Do we all know how to find the inverse?
Switch the X.
Sorry.
Switch x and y. I see looks of like understanding, I think, but you guys just aren't saying it. So instead of y equals, I'm going to say x equals. Instead of square root of x minus 2,
Square root of Y minus 2.
square root of y minus 2. You're getting a variety here, aren't you? They're all a little bit different to solve, which is good. Now, square root of y minus 2. How do I make that square root go poof?
Send it to the power.
Get rid of a square root, which is a root of 2, raised to the power of 2. If I raise one side to the power of 2, we're going to raise the other side to the power of 2. What is x to the second? X squared, x to the second. Okay. What happens when you square a square root?
Just becomes Y minus 2.
That's the poof, isn't it? The square root, you square them, they cancel each other out, because that was a square root, right? So you end up with y minus 2. Am I done? Is y by itself? No. How do I get y by itself?
Add 2 to both sides.
If it's y minus 2, I'm going to add 2. If I add 2 on one side,
2 on the other.
I have to add 2 on the other side. So then I end up with, I'm going to flip-flop here, y equals
X.
x squared plus 2. So we have x squared plus 2 over here. Minus 2 plus 2 cancels, so I have y equals x squared plus 2. How should I write my final answer?
Fine.
The F. One thing.
F negative 1 thing. F inverse of x.
F
But
versus X.
it's not so much you have to know how to say it, you just have to know what to write, right?
Yeah. X squared plus 2.
Is that it?
That's it on the solving. We've still got to talk about whether or not it's a function, right?
Yes.
Options. How do you know whether or not it's a function?
I don't suppose there's parabola in it.
X squared plus 2. X squared is a parabola. What's the plus 2 do?
Add 2 to the power.
Pushes it up 2. So if we think in terms of a parabola, is a regular, typical, upright parabola a function?
Yeah.
Yeah, that's a function. It's not sideways like the square root one was.
Yeah.
That's a function. If you're trying to plug in points like I did earlier, so if I plug in, say, 2, 2 squared is 4, 4 plus 2 is 6. Can I get any other point? No. What happens on this one is now if I say plug in negative 2, negative 2 squared is 4, 4 plus 2 again is 6. But is there anything about the range values repeating? No, it can be a function. It's okay to be a function there. Okay? Okay. Huh?
Can we skip down to the bottom?
Well, I was debating, but I'm not going to get all the way through that, and that's why I was debating if the bottom was a good one or not. You want me to skip to the bottom? I'm going to get stuck in the middle. That's what's going to happen.
Would you like one more?
Well, but they all three go together. Let's see what we can happen here. Okay. If f and f inverses are functions. Okay. So if f and f inverse are inverse functions, then this right here is always true. Remember those compositions, like that fog and Goff stuff I talked about? So f inverse composed with f and f composed with f inverse will always equal x every time. If a function and an inverse are truly a function and an inverse, they will always equal f. Now, or they always equal x, sorry. On A, before we can do B, which is the one I'd like to get to, on A, we have to find the inverse, right? They give us a function here, yes? F of x equals 5 minus 2x. How do we find the inverse?
Switch the X and
Switch the x and the y.
there's no.
But there is no y.
The f of x is your y.
The f of x is my y. Does that sound familiar?
Yeah.
That this is the same as saying y equals 5 minus 2x. Does that ring a few bells? So if I'm going to switch, instead of y equals, I'm going to say x equals. Instead of 5 minus 2x, 5 minus 2y. And we're going to solve for the 2y, or solve for the y. So how do I move a positive 5? I subtract a 5. X minus 5 is going to be x minus 5. 5's cancel. And I have negative 2y. How do I get y by itself? Divide by what? Divide by what? Negative 2. I heard it. It took you guys a moment to catch on what I needed. So divide by negative 2. Now, negative 2's cancel. Y equals. I think I did just leave it as this. X minus 5 divided by negative 2. If we're going to be official, instead of y, I can replace it and say f inverse of x. Now, f inverse of x equals x minus 5 over negative 2. You have to use this to do part B and part C. So part B, f inverse composed with f of x. First of all, remember that is, you remember how to do this? F inverse of f of x. Without doing a bit of work, I can tell you the answer. If these are inverses, barring I know made no mistakes, what do f inverse composed with f always equal if they're inverses? X. This is going to be x in the end. Now, we're going to take f and put it into f inverse. So what is f inverse? Try to decide that one. F inverse is x minus 5 divided by negative 2. Yes? Except, what am I putting in for x? We're going to put in whatever f is, which what is f? 5 minus 2x. So that's the idea of how that works. And I think that happened on number 16 in homework, and we didn't talk about that one in this class. But we took f and put it into f inverse. From here, it's a cleanup. What happens on top? 5 minus 5? Cancel. Made that line really big. So we have negative 2x divided by negative 2. What's negative 2x divided by negative 2? X. What did I claim the answer was going to be before I ever got started?
X.
X. Now, I don't have time to work this one, but this is going to be f of f inverse of 2. Guess what? I know my answer.
Is it 2?
It's 2. Okay, there's work you can be done there, but it's 2 because it equals whatever that input is, whatever that piece right there is.
Wait, every time?
Every time. Okay, tomorrow, hold on real quick. Make sure you work on homework. I may or may not leave notes videos. I feel like we got through everything, kind of. You've got to get that homework done, right? No zeros on Monday whatsoever. Okay. Have a good day tomorrow. Behave. Have a good weekend.
Can I do
Yes.
Thank you.
Mhm.